Okay, so in this video we're going to start discussing radical functions, and a radical function is a function that contains a radical. Pretty self-explanatory explanation. That's redundant. It's a pretty self-explanatory definition, so we're just dealing with a function that has a radical. So what I'm going to do here is I'm actually going to graph this, and we're going to use a t-table. We can use our calculators. There'd be a separate video using your graphing calculator, but the idea here is if I put in a negative number, we get an imaginary value, right? So I cannot graph this, so there's going to be no negative values the way that this is set up right now. If I manipulate this equation, there's a possibility a negative would work, and we'll see some situations where that occurs. But in its purest form, we're not going to be able to have any negatives. So I'm going to start at 0. So I'm going to put a empty circle or empty set here because it's not going to work for negative values. So if I put in 0, the square root of 0 is 0. Put in a 1, the square root of 1 is 1. Put in a 2, the square root of 2 is about 1.4. I'm going to start going to squares. So if I put in a 4, I get 2. So what happens with our graph as we plot these points is we have 0, and then at 1 we have 1, at 2 we have 1.4, at 4 we have 2. So we're going to see this slow growth, and it kind of looks like it tops off, but it will go to a positive infinity, but it just takes a very long time to get there. And so if I ask myself, what's the domain of this function, when we look at the domain, when we look at the graph, we can't have any number less than 0 because that would provide or give us imaginary values. So I look at this space on the graph and it's empty. So it tells me in the graph that I can't have anything to the left of this point right here, which is 0. So my domain is x, where x is greater than or equal to 0. We can take the square root of 0. Your calculator might be misleading. Sometimes it doesn't show that it connects, but it will connect. So now let's look at the range. If I look at the range of the function, I look down here, and it's empty down here. And we do have values above 0. Now also if we look at the graph, notice all our y values are going to end up being positive. Root of a positive number is going to be positive. Square root, not a cube root, a square root. So that means my range is y, where y is greater than or equal to 0. And we can look at the graph or just look at our number set and see that that's what the pattern's going to be. And finally, let's look at the 0. The 0 of the function is where the graph hits the x-axis. Well, and it hits the x-axis at 0. So the 0 is when x is equal to 0. And it's the same idea. What's going to make this guy equal 0? Well, we solve for x. It would be 0. So there's our domain and our range and what our 0 is. So this is the idea, and we're going to manipulate the radical functions to talk more about these things and graph them and find domain and range. We can look at a table of values, which we have here, or we can look at a picture. And a lot of times the picture is the easiest thing to look at. So anytime you can graph it, that's your best case for determining what the domain, range, and zeros are. Zeros might be a little bit easier because we have methods like factoring, and that makes it fairly easy without a calculator.